In this video, we're going to talk about finding the inverse of matrices, and we're going to talk about the identity matrix. In the box on the left, it says first, find the determinant. The determinant cannot equal 0. So in this case, AD minus BC cannot equal 0. Anything over 0 is undefined, and the inverse will not exist. On the right side, I have the matrix A, B, C, D. A to the negative first equals 1 over AD minus BC. In parentheses, D, negative B, negative C, and A. In the inverse, inside of your matrix, A and D will switch places. The signs for C and B will change or will become opposite. I have written some notes for you. The note says put the determinant under 1 once you find it. A and D switch places. B and C sign switch. So for example A, B, and C, we're going to find the inverse of each of the following if it exists. First thing we do is we take O, which is 2 to negative 6, 1. We take 2, multiply it by 1. 2 and 1 are A and D. B and C are 2 and negative 6. And that gives us a negative 12. 2 minus a negative 12 equals a positive 14. My notes, 1 over 14, because we put the determinant under 1. The determinant is 14. A and D switch places or positions. So A is 2. It goes in the position of D. D is 1. It goes in the position of A. Then, instead of 2, it's a negative 2. Instead of negative 6, it turns positive 6. 1 over 14 times matrix 1, negative 2, 6, 2 is your inverse. All right, we're going to look at example B. P equals negative 8, 4, 6, and negative 3. We start by multiplying AD. Negative 8 times negative 3 is a positive 24. 6 times 4 is also a positive 24. 24 minus 24 equals 0. If you remember, our determinant can't equal 0 because if we put the determinant under 1, that means that this is undefined. Your answer will be D and E because your inverse does not exist. All right, one more example. We're going to do example C. Start by multiplying A times D. So 3 times 2 is 6. 5 times 1 is 5. We take 6, subtract 5, and that equals 1. If we set this up as 1 over 1, that means that it just simply equals 1. The places, A and D switch places. So 2 and 3 switch places. 1 and 5 switch signs. So both of them will become negative. Your inverse for C is 2, negative 1, negative 5, 3. If you want to, you can put the 1 on the outside, or you can leave it as it is. If matrices are inverses of each other, once they are multiplied, the answer matrix will be an identity matrix, and the determinant of the identity matrix is 1. Right here, I have two identity matrices. The identity matrix for a 2 by 2 is 1, 0, 0, 1. The identity matrix for a 3 by 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. In example C, the question is matrix A the inverse of matrix B? First thing we have to do in order to determine this, because we're going to prove our work, we're going to multiply them. So 3 times 1 plus 4 times a negative half minus 2 is going to equal 1. So in the first position of our matrix, once they're multiplied, we have a 1. In the second position, 3 times negative 2 plus 4 times 3 over 2. 3 times negative 2 is a negative 6 plus 4 times 3 is 12. You divide it by 2, you get a 6. Second position of our matrix is a 0. In the third position, we take 1, multiply by 1, add 2, and multiply by a negative half. 1 times 1, of course, is 1. 2 times a negative 1 is a negative 2. And if I divide by 2, I get a negative 1. 1 minus 1 is 0. Third position is 0. In the fourth position, we have 1 times negative 2 plus 2 times 3 over 2. 1 times negative 2 is a negative 2 plus 2 times 3 is 6. If I divide by 2, I get a 3. So I'm left with a 1 in that last position. That is your identity matrix. And if you find the determinant, you get 1 minus 0. So your determinant of that matrix is 1. So for example, C, is matrix A the inverse of matrix B? Yes. Multiply the two matrices to get the identity matrix. And remember, the determinant of the identity matrix will be 1. Now there is a U-try problem. I definitely want you to try this, and I'm going to go ahead and tell you the answer to it is yes. If you don't get that, please send me an email and let me know.